Today we are going to talk about water and pH. Water is one of the most important molecules in the human body. It makes up 70 to 90% of living things, and so it's super important for many different reasons. One of the things that you may remember from the last lecture about atoms and elements is that water is a polar molecule. So remember, what that means is that the electrons in a water molecule are shared unequally. And that means that there is a positive end of the molecule and a negative end of the molecule. So the oxygen end has a slightly negative charge, and the hydrogen end has a slightly positive charge. Contrast that with a nonpolar molecule like ethane, for example, and you'll notice that ethane does not have charges. There's not a positive or negative charge. The molecule is just neutral. And again, water molecules have a negative charge on one end and a positive charge on the other end. Because water is, in fact, polar, it forms hydrogen bonds. So that means that the attraction of the positive end of one molecule is attracted to the negative end of another. So when you look at this diagram, for example, you can see here's the oxygen atom from one water molecule, and it has a slightly negative charge, and it is weakly attracted to this hydrogen atom from a different water molecule. And so between those two atoms, this dotted line represents a hydrogen bond. A hydrogen bond is a weak attraction, again, between the negative oxygen and the positive hydrogen between two different water molecules. And hydrogen bonds can form between many different water molecules. So you can see in this diagram, there's 5 water molecules. There's 1, 2, 3, here's the 4th one, and here's the 5th one. And they all are attracted to each other by hydrogen bonds. One of the effects of the formation of hydrogen bonds in water is that it leads to surface tension. So if you've ever seen like an insect that can sit on the top of water without falling in, it can sit there because of the hydrogen bonds in water. Hydrogen bonds are also quite easily broken though. That's why you can stick your hand into a pool of water without any huge amount of resistance. Water is also called the universal solvent. In chemistry, typically we have a saying that says like dissolves like, meaning that things that are polar can dissolve other polar substances or ionic substances, and non-polar substances can dissolve non-polar substances. So in water, for example, because it's polar, salt will dissolve in water, and sugar will dissolve in water. But oil, which is non-polar, does not dissolve in water. Oil is able to dissolve things like into soap, right? So that's why we use soap to clean up our dirty dishes that have oil on them, because soap has a non-polar properties, so it can dissolve oil and pick it up off of our dishes and allow them to get clean. Water does have some additional characteristics that are pretty important. So one of those is that water is extremely good at storing heat, and that allows your body to maintain a constant temperature more easily. So once you warm up water, it takes a long time for it to cool down, and that helps your body maintain a constant internal temperature, even when the external temperature outside of your body is changing. Water is also in possession of a property called cohesion. That means that water can stick to itself. That's that surface tension thing we talked about earlier, and it's caused by hydrogen bonds. So as we discussed earlier, the negative oxygens in a water molecule are weakly attracted by the hydrogen bond to the positively charged hydrogen atoms, right? Hydrogen bonds also help water to form the crystal structure that it is in when it is a solid, which of course we call solid water ice, right? And so you can see there's a lot of hydrogen bonds in ice that hold the water in place in a specific structure, and then it's frozen when the molecules stop moving as much. And then when ice warms up and starts melting, we still have hydrogen bonds, but there are fewer hydrogen bonds in liquid water because liquid water is much more fluid. The surface tension of water, or the number of hydrogen bonds essentially that are found in water, decrease as water gets warmer, and that's partly because the molecules become more active and are less likely to want to be bonded to each other. And of course, once water boils, which is at 100 degrees Celsius, there are very few or no hydrogen bonds because the molecules are very active and they are further apart from one another. Here's a picture of that effect of surface tension that's caused by hydrogen bonds, right? So here's a spider and it's sitting on top of the water. You can see how the water kind of gets a little depression where his leg is sitting, but it doesn't break through the surface of the water because of that surface tension. Water is also capable of something called adhesion. So cohesion was when water sticks to itself. Adhesion is when water sticks to other substances. So you might see adhesion, for example, if it has rained and you see a water droplet on your car. The water droplet can stick with hydrogen bonds to the surface of your car, and that allows it to form that bubble that you see when the water collects on the top of a vehicle or another surface. Another characteristic of water is that it expands when it's frozen, which means that ice is less dense than water and can float, which is really important because if you think about it, if water froze from the bottom up or became more dense when it froze, Minnesota fish would be in a lot of trouble. You can see that with these terrible illustrations that I drew because I'm not an artist. Here we have a lake and the fish are swimming in liquid water and it's great. They can breathe, they can move, everything as well. In Minnesota in the winter, the ice freezes. And since ice floats, the ice is on the top of the lake and the fish can still swim around in liquid water. However, if ice were to freeze and then sink, the ice would continue to freeze all winter instead of forming insulation on the top of the lake like it does currently. And so every time the ice would freeze, it would sink to the bottom. And then you'd get more and more ice on the bottom of the lake as the winter went on, and it's possible that the fish would run out of the water or run out of liquid water and the lake could freeze solid. So it's really important for our Minnesota wildlife that live in the water that the ice floats. And here you can see an example of ice. This happens to be an iceberg in the ocean, but ice floats in the ocean just like it floats in a freshwater lake in Minnesota, and you can see that it sits on top of the water. Another concept we need to talk about today is pH. pH is the measure of how acidic or basic something is. You may have heard those terms, acid and base, sometime in your life, but you might not remember what they mean. So we'll start with what happens with water. So first, water can break apart naturally into hydrogen ions and hydroxide ions. Hydrogen ions have a positive charge, hydroxide ions have a negative charge. And this makes sense, right? Because we know the chemical formula for water is H2O. And if you'll notice, hydrogen and hydroxide make up the two parts of the water molecule. So, if water breaks equally into hydrogen ions and hydroxide ions, the pH is neutral, which is 7 on the pH scale. And that means that there's the same number of hydrogens to hydroxides. So anytime you have the same number of hydrogen ions and hydroxide ions, the pH is neutral and it's a pH of 7. If something is acidic or an acid, that means it has more hydrogen ions. And if something is basic, it has more hydroxide ions or negative ions. So pH then measures how acidic or basic something is. So acids, again, are substances that form hydrogen ions when they're in water, and bases form hydroxide ions when they're in water. And acids will always have more hydrogen ions than hydroxide ions, and a base will always have more hydroxide ions than hydrogen ions. And then we're going to draw a pH scale. So the pH scale goes from 0 to 14, and we can assign a pH value to different chemicals. Remember, if something has a pH that is below 7, it is an acid. And if it's towards 0, it's a strong acid. If it's towards 7, it's a weak acid. And then if the pH is above 7, then it's a base. And if it's a base that's like a pH of around 14, it's a very strong base. And if it's a pH of, like 8, it's a weaker base. And lots of different household chemicals show up on the pH scale. So for example, if any of you have ever drank milk, for example, that has a pH of around 6. If any of you have ever eaten an egg before, they have a pH of around 8. If anyone has ever done laundry and washed your clothes with bleach, they have a pH of around 12. And if anyone has ever had lemon juice before, that has a pH of around 2. So there's lots of different chemicals that are on the pH scale, and some of them are stronger acids and some of them are weaker acids, and some are strong bases and some are weak bases.